All right, are you excited? Let's go. Let's go with DAPPS. So we're going to talk about various things about DAPPS. First, the blockchain. What is it? Before that, we'll talk about Satoshi Nakamoto, then the blockchain, and then DAPPS. All right? Sounds good? Awesome. And before that, Jumana, look, in Slack, we cannot see it now, but on Slack, my God, where are you? Oh, I lost the connection. Oh, there's no connection, right? On Slack, I posted the link to the Zara chapter in one of my books, where you can learn the real competitive advantage of Zara, which is not technology. Okay? And whoever says that, they don't know anything about Zara. And my neighbor in Barcelona know the founder of Zara, which is the richest man in Spain, when he was young. They worked together. So he knows all the stories. He used to be he has a transportation company, and they know each other. They have very interesting, but it's not the technology. Awesome, cool. So let's start with Satoshi Nakamoto. Do you know who is Satoshi Nakamoto? Fun.
Bitcoin, yeah, Bitcoin.
What, Bitcoin or blockchain? What?
Bitcoin.
Okay, and how did he do it? Do you remember?
It was very long time back.
He wrote a paper. You can write papers and publish on magazine, or you can write papers and put it on the internet. So he wrote a white paper called Peer-to-Peer Cash System, and he called it Bitcoin. This was in 2008, so it's already 11 years. And he published the paper, which is basically a protocol. So let's see the paper. Where is it? Bitcoin paper. I recommend you download and read this paper. It's everywhere. He published this paper. Satoshi Nakamoto at Satoshin GMX. This is the paper. You see it? That's pretty nice. Yeah. He published this paper, and then through some chats and some online community, he hired or talked to some developers to start implementing the protocol on an application so it works. And after a while, they got a prototype running. Yes? So remember that 2008 was when the financial crisis. So people were very upset because the government had to give money to all these banks who already have a lot of money. And you've seen The Wolf of Wall Street. Yes, the movie. Have you seen it? Yeah. Well, that's who we gave money to, these kind of people. So there was a lot of anger. So it's very interesting that it was in 2008 that this paper came out. And it's very interesting that the guy remained anonymous. It's also very interesting.
You put the paper on Logo? You put the paper
In Slack? Yeah. So you can, I'll put it. I'll put it on Slack. It's okay. Oh, it's already there. Thank you.
Yeah.
Good job. Bonus point for you. Okay. So how does this work? How do you make electronic peer-to-peer cashless system? And why do you want to do it? So first thing you need to understand, electronic payments are very expensive. How much? Do you know how much? How expensive is it?
No.
Yeah. When you use your Visa card,
10%, 3%, I think.
4%.
4%.
When you use this, how much you have to pay to Visa to pay? You pay it, by the way, not
4%.
4%. Why does it take 4%?
Charging of
What? What is it? Why is it so expensive?
Because well,
Remember how much money is this? Of all the money that people pay with this, 4% has to go to Visa or MasterCard to pay for the costs. And Visa or MasterCard are not super rich either, right? So what's going on? Why is it so expensive or inefficient?
cost is low.
Why is it so expensive?
I secure the security mechanism. I mean, they secure your money from one person.
A lot of that money is spent on Visa and MasterCard fighting the hackers and security. A big part goes to the terminals, the hardware. Another part goes, every time you use it, they have to make a phone call to the bank, send some password, come back. Yes? It's very inefficient.
Now, every time we use a phone call,
Every time you use this, the terminal uses the internet, but before they used to make a phone call, which has to be paid. And now they use the internet, but you have to pay for the internet also. And you have to pay for the fraud. When somebody steals money from your card, Visa has to pay for it. So my friend now works at American Express, and his job is, he's the data scientist in chief, and his job is to make a model, AI model, to detect which transactions are people trying to steal money. So they have a very high accuracy, and every percentage point of accuracy he improves, he says, yeah, every percentage point is 4 million I saved to American Express. It's good? Yeah, it's good, yeah. He was a professor here, then he moved to London, now he lives in New York. Okay, cool, excellent. So Satoshi came up with this idea. Let's understand how this works. We'll watch a video because I think it's a bit better. Let's see. You ready? Taking notes?
Popular nowadays. Blockchains are incredibly popular nowadays. But what is a blockchain? How do they work? What problems do they solve? And how can they be used? Like the name indicates, a blockchain is a chain of blocks that contains information. This technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents so that it's not possible to backdate them or to tamper with them, almost like a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. Now, a blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside the blockchain, it becomes very difficult to change it. So how does that work? Well, let's take a closer look at a block. Each block contains some data, the hash of the block, and the hash of the previous block. The data that is stored inside the block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about a transaction, such as the sender, receiver, and the amount of points. A block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its contents, and it's always unique, just as a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change. So in other words, hashes are very useful when you want to detect changes to blocks. If the fingerprint of a block changes, it no longer is the same block. The third element inside each block is the hash of the previous block. This effectively creates a chain of blocks, and it's this technique that makes a blockchain so secure. Let's take an example. Here we have a chain of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2, and number 2 points to number 1. Now the first block is a bit special. We cannot point to previous blocks because, well, it's the first one. We call this block the genesis block. Now, let's say that we tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks verifies the block to make sure that it hasn't been tampered with. And if everything checks out, each node adds this block to their own blockchain. All the nodes in this network create consensus. They agree about what blocks are valid and which.
I don't like how he's explaining it here, but basically, you have the Bitcoin network, and let's say I want to send money to him, right? So I tell the network, I want to send money to him. And the network says, okay, wait a minute. Let's say you want to send money to me, and various people want to send money. And various people say, we want to do all these transactions. And these transactions are announced, and they're put on like a list, waiting list, okay? So let's say I have a computer running the Bitcoin protocol. So I would look at this list. I will take the top 5 or random people waiting. I will make a block with these transactions. And I will do this proof of work, which is basically running the computer, spending a lot of electricity, trying to solve a puzzle, okay? So at this moment, I pick up 5 or 6 transactions. I build a block. I try to solve the puzzle with this block. At the same time, somebody else, somewhere else in another country is doing the same with maybe the same transactions or different transactions from his country. And at the same time, all the computers are doing the same with transactions they pick from the pool who are waiting to be transacted. The first person of all the computers that solves this puzzle.
It depends on the solver first.
Yes. So how do you decide whose block goes into the chain, right? How do you decide it? So the first one who solves it, so it's basically random, because one day I will be me the first, the other day will be somebody else, right? In this way you prevent the hackers spamming the chain, because you don't have the right to add until you solve the puzzle, and the puzzle, to solve it, it requires a lot of computing power, which means money, which is what the opposite of spam. If it costs money, you cannot spam. Does this make sense? That's called the consensus. So it's basically random. Whoever solved the puzzle first, and one day it will be you, the other. In this way,
It's hard to hack it.
that's why it's hard. One of the things. The other is that all the computers are everywhere in the world, so you can destroy many computers. Everybody has a copy of the blockchain. If there is a war, no problem. If there is a fire in your house, no problem. It's distributed. Right? Got it? So that's proof of work. So to make it expensive, the right to add something. Yes? When I gain this right, when I solve the puzzle, I get some money. So on average, for example, if I'm very unlucky, I run my computer working for the blockchain, and let's say I'm very unlucky and I spend a lot of electricity, and I never once I was able to solve the puzzle before anybody else, so I never got some small price to pay for the electricity. Well, now I was unlucky, but on average, I will earn enough money that I can pay the electricity and run the computer. Make sense? No, anybody who installs the blockchain protocol in the computer. So upstairs we install the client for testing. So we run it, and you can see how every 1 month it will make $1 because what X, Y, Z. Does it make sense? Good.
So it's the computer or people are responsible to
Right.
solve it so they are not use it.
The users are, I have Bitcoin and I want to send it to his, by the way, everybody has an address, right? A wallet and an address. So if I want to send money to him, I use an address, his address. It's very simple and very fast. because if I want to send money to someone today, it takes a few days through the bank, right? Especially if it's in another country. In blockchain Bitcoin, it takes 10 minutes. So a few years ago, 2 years ago, I was in this meetup, blockchain meetup, and I make a key holder. So I sold it, and the guy paid me in Bitcoin, $30. So in 10 minutes, I had the money.
Because you have an account in Bitcoin.
I have an address. So I gave him my address, which is a QR code. I show it to him. He goes, blip.
But you can't retrieve that money physically, right?
Well, it's Bitcoin money.
So you can't retrieve it.
I can retrieve it through the exchanges, which is Coinbase, which is this one. In UAE, you have Coinbase works now in UAE. So to retrieve money, so to convert Bitcoin money to physical money, but why do you need to convert it to physical money if you can buy things and sell things with Bitcoin? I can buy things on Amazon with Bitcoin. I can pay for my air tickets with Bitcoin in some places.
But they are convertible.
They are, if you need to, yeah. But in general, you don't need to. It's like other money. It's like dollars or euros.
Okay, if they are convertible, 1 dirham equals how many Bitcoins?
Here you have it. 1 Bitcoin.
15,000
Really?
No.
Yes. Yes.
And how much
You
have
tried
in
it?
Bitcoin?
Huh?
How much you have it?
So now you have
I
to
cannot
convert-
reveal this information, but I just tell you I sold all my Bitcoins and I bought a Toyota Prado.
What? I missed this one?
It's okay, nothing.
Do not tell me.
Bitcoin Malaka.
Yeah, how many Bitcoins? So I have friends who have many Bitcoins.
And every Bitcoin is 14,000, I think.
My student who was here, he had a lot of Bitcoins because he started early and he became rich
Started early when? 1 year.
5 years ago.
It was like
Bitcoin was 10 dirhams or 20 dirhams. Anyway, so he invited me to a trip to Africa, Kenya.
5 years ago was almost 10,000, but
Yeah, he started earlier.
10 years, 8 years.
Anyway, so do you see the genius of Bitcoin? You have miners, who are the people running the nodes. You have users, and you have the protocol. And the genius of Bitcoin is that greedy incentives. Miners, they do Bitcoin not because they believe Bitcoin is good for society, because they want to earn money for themselves. So greedy incentive, so Bitcoin is an incentive protocol. You get it? Where from greedy behavior of many people, a service, which is very good, is provided to transfer money between people. It's incredible. You get it?
When we do something for free.
Exactly, but that's the genius of Bitcoin. So many people misunderstand the Bitcoin paper. No, Bitcoin paper is just an incentive protocol. That's it. With some technology. But the genius is like, okay, some incentives and something comes out of it, which is absolutely incredible, which is the ability to send money, big quantity or small quantity, more efficient than Visa, MasterCard, or PayPal. So today, if I want to send $10,000 to my friend in Chile, I will have to pay 1-2% commission fee to transfer from dirhams to dollar and from dollar to pesos. The money will keep my money, the bank will keep my money for 3-4 days. And then I will have to pay a commission of $50 probably on top of that. Yeah. When I use Bitcoin or Ethereum to send the money, it takes 5 minutes, and the commission is $1 or $2. Wow, that's wow. Okay,
Yeah.
that's awesome.
So the 3 main advantages are the time, the quickness,
Speed. Yeah.
the speed,
Yeah.
the security,
Yeah.
No, security. Yes, security.
Let's talk about security later. Yeah. And
and the cost, and the saving.
I don't have to trust a bank. Remember, Nobody owns Bitcoin. It's just a decentralized network.
Yeah, but the bank, if it's stolen money, will be back.
Okay, Abdullah has a very good point. Like, if so this is a very interesting thing. Some people say, oh, I have Bitcoin, right? So some mafia guy go to his house and breaks their legs until they get the Bitcoin. Once you send the Bitcoin, you cannot recover it. It's not reversible. It's like, halas.
This is one risk of it.
It's once people,
Backdrop.
one service the banking was providing is that if they do the same with the bank will say, who are you sending this to? They will check something.
Why are you sending it also?
Right, so I cannot go to your house and break your legs and then say, you must send me all your money to my bank account, because then the police will know, right? That doesn't work. So at the beginning, people said, oh, Bitcoin is awesome because it's cheaper, faster, and it, but also the bank provides a service, which is this 4% we talk about, which is this one, which is also interesting, yes? Okay. So for small transactions, Bitcoin is awesome, because if I want to send $10 to Chile, it will cost me $60 to send it. Because of that, it doesn't work. But nobody will break my legs for $10. So you get it? Good. So that's one thing. The other is that today, if you want to pay $1, like let's say I go to your website and I say, oh my God, Abdullah, he wrote this post, it's beautiful. I'm gonna send him as a thank you note, 1 dirham. Can you do that today? You can do it, but you will pay $1 in transaction fees. And because of that, people don't do that. But with Bitcoin, you can do that. I can send a small amount for a very small fee. Does it make sense?
Yeah.
So that's what they call the economic internet. The economic internet is enabling transactions, small transactions, what they call micro transactions in the internet, which now are not possible because there's this step fee of $1, $2, that if you don't spend more than $2, the fee is bigger than the transactions. It doesn't make sense. Awesome? Awesome. So that's it. So how do you buy Bitcoin or get Bitcoin? One way is to mine. So you can mine, put your computer to mine. So if you did that 10 years ago, you could get 1 Bitcoin every month. But now you will get 1 Bitcoin every 10,000 years. So the other is to buy it. You can go to a website called Coinbase and you can buy Bitcoin there. In here we have one called BitOasis, but I don't know exactly what you get. Once you make an account, you get an address and you can create Bitcoin addresses and you can put your money there. And then once you have this address, you can say, send 0.01, which is $50 to Jose, and you can buy a pizza, or you can do this and that. Make sense?
When do you increase, decrease?
The value?
Yeah.
What do you think?
It's random, right?
It's random. Yeah, there's a lot of speculation. So I have acquaintances here, very young. One of them made $8 million last year trading, but he doesn't sleep. He's just all the time watching. And the other guy made $5 million.
My husband is doing that, but he's not getting it.
You tell your husband to keep the money under the mattress.
He's 24/7 on that. And
No! Seriously? This is a problem. Are you kidding me?
no,
That's terrible. Tell him to stop. Now it's a very bad time.
No, he's not very patient to wait.
It's very dangerous now. Like, I wouldn't touch it. All my friends get out of Bitcoin already. So, all right.
You already have your team, that's why you can connect your Bitcoin, right? All your friends.
Okay, good. So Coinbase, good. So that's it. You see some coins here, Bitcoin, Ethereum, Litecoin. These are different protocols, different coins. Bitcoin was the first one, But there's another one called Ethereum. So Ethereum is a more sophisticated system that allows a thing called smart contracts. So you can, in Bitcoin, I can send money and stuff like that, coins to people, to addresses. In Ethereum, I can have a small code that executes automatically if something happens. And that enables what we call smart contracts. Okay? Good. And what is this? Ripple. Ripple is a different system. It's a system made by the banks to use these kind of technologies to send money between themselves, because they realize the way we do it is very inefficient, this way is faster. So that's Ripple, basically, the banks doing it. It's not a real blockchain or Bitcoin. It's not decentralized, it's centralized. But still, it's good for the banks. Yeah. I wouldn't touch it either.
What does it cost?
Ripple, XRP, Ripple. So if you're interested, my friend works at Ripple Dubai, so if you want, we can go and visit them one day. Ripple. Is this Ripple? Ripple is not a decentralized network. Well, okay, yeah.
It's only for banks?
It's owned by the banks. So if you don't trust the banks, because many of the people that use Bitcoin, they use Bitcoin because they hate the banks or they don't trust the banks. So okay, so Bitcoin is known also as digital gold. Yes, very good. You're losing money? How is it going? Not bad. Yeah. Questions? Okay. So this blockchain stuff, there's a chain, it's like a database, you can store things, addresses, hash of, you can store little bits of data. So there's the thing is that it's a database, think about that, it's like a database. Once you write, you cannot erase, because a lot of people have a copy. It cannot be destroyed. So sometimes you have a database, a data center, somebody throws a bomb, the data is lost, right? This is different, cannot be destroyed. It means it can never be erased. So if you put there something that's a mistake, it will be there forever. And it's trustless. I don't need to trust anybody. When I send money to him, when I use the bank, I trust the bank that they will trust. But here, no, it's called trustless. I don't need to trust anybody. It will happen automatically because the greedy behavior of the miners will make it happen. Decentralized, unbreakable, trustless. So think about a database that once you write, nobody can erase. So that creates interesting applications. For example, your grades online. Let's say we put them there, and 50 years later, even the university doesn't exist anymore, which happens, your grade's still there, so you can still prove that I took this course and I got this grade, right? So there's this project to put all your certificates, things online, because now what do? They give you a piece of paper. It's like so retarded. Like, I'm going to show you my certificate from Japan. When I got a job here, the university told me, we don't believe you that you have a doctor from Japan, so call your, huh?
They are right.
Yeah, sure, they're right. So they made me call my uni.
How can I know if it's
Yes.
acceptable or not?
So they made me tell you.
You and like a fake one or
Exactly, exactly. So they made me call my university, and they said, tell them to send us a certificate. So I called my university. Thank God I had still some friend there. And the university secretary print this paper, and they put this Japanese stamp, which here they don't know what it is, but doesn't matter, right? They put this Japanese stamp here also, and the signature, which is, I don't know if it's real or not. And then all my grades and everything here.
That's good.
And then they send a letter, to here, and now the university here believes this is real. But we all know that anybody can falsify this easily,
Yes, yes.
easily. Photoshop is awesome these days, right?
Yeah, yeah.
So, what's better? Blockchain, right? So, if when I took this course, my university put this information on the blockchain with my name and my grades, no.
Now we have this in the EU.
We have it. So 20 years later, 10 years later, nobody needs to print this. You just need, look, this is the address of, this is my address, my student address. Check it.
Yes.
Oh, it's there. And if somebody changed something, the hash will not compute. You know, it's tamper-proof. So now there's all these projects. So this is expensive, slow. Blockchain is fast, reliable, and more secure. So now there's all this wave of how to make apps that use this to take advantage. For example, typical application, grades. The problem is not to put the grade on the blockchain. That's super easy. The problem is the user interface. How to make it easy for the user to use an app that uses this technology. Last year, the students made a project of falsified bags, how to prove that a bag is real using the blockchain. Is it possible or not? So that's interesting. If you manage it, you will be rich, and you get an A also in the course.
So blockchains are not only for financial transactions?
Correct.
I have a question.
Yes.
If I upload or send a document by blockchain, and I don't know if it's real or not. So the receiver may receive it as a wrong document, right? So is there anyone or any part of blockchain just to make sure it's real? So how can I trust it?
That is a different problem. So blockchain provides you some services, not all the services you need.
So we can depend on even with money.
You can depend to
Because you said
say
it's hard
that
to change.
10 years ago somebody put your grade and it was this one. And so that's it. But at least you know that nobody will change the grade or the name, you know, that whatever they put 10 years ago, that has not been changed. That's what it ensures. For example, this is good for prediction markets. If I predict that this will happen in 10 years, I can write it on an envelope, or I can publish it in a blog post, right? But if I put it on the blockchain, it's ensured that my words are those ones and nobody changed them. I don't need to trust Google that they will keep the blog post of 10 years ago.
Okay, so it's not only for money blockchain? It's not only to
Any
transfer-
application where you need,
I was thinking blockchain is only for money transactions,
No.
financial transactions,
No.
sending and
Bitcoin.
receiving money, best.
Bitcoin is a
no, you can use Bitcoin to timestamp things also. So Bitcoin has a bit of code, but it's not very good. It's very primitive.
Okay, I mean blockchain.
But
no.
blockchain is blockchain. One application of blockchain is Bitcoin. Many people confuse both, but it's not the same.
I thought that it's strongly attached to each other.
No. So blockchain, you store data, right? In the case that the data is numbers, coins,
Okay.
then it becomes Bitcoin. But you can
Fine.
use the same protocol and call it a different coin name, like Jose coin or something, or Jumana coin, which many people do.
Okay, okay.
Make sense?
Yeah, makes sense.
Now, Bitcoin was the first, it was designed for low bandwidth, so it's very simple and primitive. Because of that, it's not great. because it had to work even if the internet connection was bad. But then they designed a new one called Ethereum. Ethereum is an evolution of Bitcoin blockchain, and it allows smart contracts. So publishing code that when you send money, it runs when I send money. So imagine he has an address which is a smart contract. He published it. I send money to this address, the money will make the code run and execute. And he can check various things like, is this coming from Jose? If it's coming from Jose and it's this amount, then send money to this other account. So it's like if X, Y, Z happens, this happens. And then you can execute things like. So last year, some students created a Dubizzle based on Ethereum. So where I could buy a car using a escrow account. So the problem with buying is that I give you the money, you give me the keys, right? I have the money in the keys, bye. So, right? So how do you solve this problem? It's called escrow account. He sends the keys to the escrow account, or I send the money to the escrow account. The escrow is a third party that checks when Jose has received the keys. Jose will tell me I have received the keys, and then I transfer the funds. This is done manually today, and we both have to trust the escrow manager, which is a guy in a bank. With Ethereum, you can make this guy can be a contract, which a contract is not a person, it's a robot. It doesn't have conflict of interest. It's much better. It cannot run away with the money because it's just a code. It's much better. So they made this Dubizzle where I would buy the car by sending the money first to the escrow account, which is a smart contract, and then when I receive the keys, I send another message, and the funds are released. But if I don't send the message, I cannot get the money back. So I don't have incentive to steal either. Does it make sense? Cool. So this is a very high-level overview, and there are tutorials to learn how to program a DApp. Yeah, I know it's a bit complicated, but it's worth it. It's a bit too much, I think. But it involves web, JS, JavaScript, Node.js, all the cool technologies that are changing the world today. And finally, there is this website, and we stop. It's called State of the DAPPS. And here you will see listed 3,000 DAPPS. The most famous is called CryptoKitties. So one thing you can do with blockchain is digital identity. So CryptoKitties is a cat game where you have a cat which is unique in the world because it has a hash value which is in the blockchain. And it says this hash value, which is a cat, it's like the plate number of a car, belongs to Jose. Yes, I own it. So if somebody makes a copy of my cat, it doesn't work because in the blockchain it says, no, it belongs to Jose. So they can make as many copies as they want, but in the blockchain it says, I own it. Okay? When it's a physical portrait or something, there's only one, and if you want to falsify it, you need to spend a lot of time, right? With digital, you just make a copy in the file, right? So that doesn't, you don't have protection. With blockchain, you have this protection to say who owns it, even if it's digital. So that enables digital copyright, digital owning, okay? Got it? So CryptoKitties is a game where you can own cats. The cats can breed, and you can buy cats. And because everything is tracked through the blockchain, nobody can make illegal copies, which is super easy, and sell the cat because everything is in the blockchain. So that enables a game where you trade digital goods, which is a revolution. Get it? Awesome. So you can check CryptoKitties, and there's some videos on how it works. It's a pretty successful game.
Okay, so Dr. We were planning to talk about DAPPS. That's why we came to blockchain. I don't know what
The
brought us
DAPPS
to blockchain.
are so the blockchain is the underlying technology. Bitcoin uses blockchain.
Okay.
Ethereum, which is a more sophisticated version, uses a different version of blockchain, but more or less the same. They all work the same. The other coins like Cardano, Neo, Ripple,
Yeah, okay, but what's the relation between this and between DAPPS?
the DApps are called distributed applications.
Mm-hmm.
And
One of the application is blockchain.
no, an app that uses the blockchain to do something is called DApp.
Okay, now I got it.
Make it?
Again, with that blockchain?
An app that uses the blockchain to as part of their functions, it's called DApp, distributed application. So for example, some people are doing insurance applications where the insurance uses the blockchain to reduce costs of traditional insurance.
Now I understand.
So maybe
DAPPS is the responsible of solving these.
maybe you have an app on the phone that uses blockchain to insure XYZ, and it's your insurance for whatever. So there's wallets. That's an app. The wallet stores your money, and you can pay with a wallet and uses the blockchain. That's an app.
Yeah, but it has to be huge, or it can
No,
be, it can be simple.
yeah. The Dubizzle project the students did. That's an app. Yes.
So we can create a DApp as a project for this course,
Yes, and you don't have to program it. You just need to think about it
the item.
and design it a bit, the structure, the architecture,
Okay,
make a prototype using LeanUX,
okay.
show a mock-up, and just make sure that it works. So blockchain cannot do everything, okay? So if you say it does this, like say, well, if I do this, I can hack your app very quickly and it doesn't work, right?
And blockchain is compatible with certain programming languages or all?
Yes, so we use web JavaScript, and there are APIs to,
Python.
there are Python APIs to access all the blockchain stuff.
Okay,
Make sense?
makes sense.
Awesome. Okay, so we'll stop here, and you will let me know the next week, not the next, if you want to go deeper into the coding of smart contracts or not. But the idea is that the next month, until the course finish, because we have 2 months left, something like that,
Less, almost, one and a half.
that you work here designing this final project, which you can choose to make it an app, a chatbot, or a combination of, or a data science project, like we saw Berkeley Data Science. Got it? So now you need to make groups and think about